So what we're going to do today is we're going to go ahead and see how we can measure the output power of our transceiver, our Xiegu G90, using an oscilloscope and a dummy load. So the idea then is that we want to the output power of our transceiver. So for that, the way we're going to set this up is we're going to go ahead and put this essentially in series with a dummy load. So let's sketch out what we intend to set up. First, what we're going to have is our Xiegu G90. And then what we're going to have is our dummy load. And then what we're going to use is an oscilloscope. The oscilloscope that we're going to use is going to be based on a laptop. It's actually the 2204 Picoscope. So this is connected via USB to a box, which is the guts of the oscilloscope. And it's going to actually have our measuring circuit. So out of this transceiver, we're going to have our antenna lead coming in this direction, and it's going to go up here to what we essentially have as a connection in here, but in T, we're going to be coming out and we're going to be going into the times 10 probe of the oscilloscope. Remember, this right here is just our laptop running the Pico software that essentially makes for a software oscilloscope. So that's the idea. And then what we're going to say is we're going to measure and compare our power actual or measured versus our power displayed. In the G90. One more thing to note is that we need to go ahead and do some formula derivation of what exactly we're wanting to do. So again, we're going for power, which if we remember is voltage times current. Now, we also know that Ohm's law tells us that V equals to IR, which implies that I equals to V over R. Now, if we go ahead then and take this expression for I and insert it into our expression for power, we end up with, in other words, this implies or becomes V equals to V times V over R, or V squared over R. Now, the power that we're going to be using, of course, is the RMS power. So we have to do one bit of adjusting here. In other words, this power right here is going to be the RMS. But the reason we have to do this conversion is that we're going to be measuring volts peak in the oscilloscope. Actually, we could measure volts peak to peak, and that would be equal to the volts peak times 2. So then volts peak, which we divide here, or just measure volts peak directly off of the scope, is then equal to 1/2 V peak to peak. And the other bit that we need is that VRMS, which is what we're looking for, in terms of VP, is square root of 2 divided by 2 times V peak. So again, just recapping, either we measure volts peak to peak off of the scope, or we measure volts peak. And then once we have that, we can go ahead and insert volts peak here, and then obtain our voltage RMS. Once we have voltage RMS, we take that fellow and insert it into here, and we get our power. So that's going to be the plan of attack. Now let's look at our experimental setup and then do some measurements. At the beginning of this experiment, then, what we're going to confirm is that the dummy load is indeed giving us a 1-to-1 SWR. So the G90 has the capability to give us that information, to do a sweep. So we take the power key and just hold it down. We notice right here that the G90 is showing a 1-to-1 SW. You barely see the yellow line hugging the x-axis, which is actually in a white line configuration, but the yellow and the white are overlapping, and down here you actually see 1.0. So we actually have a 1-to-1 SWR to start out our experiment. Okay, starting over here with the Xiegu G90, we have it right here, and back here we have the output lead coming out there, and it's going through this coax cable, which is, I believe it's an RG8X, coming into our dummy load. This dummy load I just got today at a Hamfest, and it's rated up to 1,000 watts. So for the powers of up to 20 watts that we expect, maybe 25, 30 most, we should be okay. Now the setup that I've got over here are some crossovers, because this is PL259, SO239, I'm going to BNC. And the reason I've done this is that I want to use the times 10x probe. So I had to go ahead and set this up so that it goes in there, and the grounding goes right out there on the sheath of the BNC connector. And on this side right here, we have the rest of the setup. That's the oscilloscope right there. That's the Picoscope 2204. We're coming in through the yellow lead. And this is going to be our oscilloscope display, this laptop, this old laptop. So that's the intent. Now let's go ahead and furnish a voltage through our setup. For that, what we're going to do is we're going to see the power level, and we see that the power level is set to 5 watts. So then we go back here, and now we go ahead and apply a voltage. And right there, we have a voltage showing here. Up in this area right here, essentially we position the cursor here on the top part and on the bottom part, and we measure 51.32 volts. 51.32 volts is what we're going to write down in our results. So we write down 51.32 volts. We won't put the units here so it's not to confuse matters. So we'll go ahead and turn on the calculator. 51.32, enter, 2 divided by, that becomes 25.66. And we're going to play a little bit loose on the significant figures. We'll just keep it to 2 significant figures. So the voltage RMS then is the square root of 2 over 2 times this value. So that'll be 0.707 times. So that gives me 18.142. Okay, and then that one we want to square. So we'll go ahead and do purple square. That's that number. And then divided by 50. 50 divided by. That gives us an actual value of 6.58 watts. Again, we're not going to clutter up the display with units. However, notice that according to the Xiegu G90, the P display, the power displayed, was 5 watts. So a little bit higher than what is displayed. We'll keep on going and filling out maybe for 10, 15, and maybe 20 watts. Okay, so now what we've done is we've gone ahead and increased the power to 10 watts on the Xiegu G90. So now what we do is we go ahead and furnish the signal. And let the autofocus or auto threshold apply. So then we increase this a little bit higher to get the envelope. And then the lower threshold, we lower that guy a little bit more. And what we're seeing right up here is 69.06. So now we will write 69.06, enter, 2 divided by 34.53, 0.707 times 24.41, and then what we want to do is to square, so we go squared and then divide by 50. So we get 11.92. And again, our P displayed, we saw that to be 10 watts. Let's go ahead and put watts in this last column so that it becomes very clear that we're talking about voltages here, and these right here are volts. I don't want to put any more units there, but voltages in volts, power in watts. And so let's continue filling out the table, maybe for 15 and 20, and see what we get. 15 watts of power in the Xiegu. And let's go ahead and key up. And see what we get. We go over here, we increase the top indicator so that we can get the envelope curve, and then do the similar change of the envelope curve down here. Let's see if I can get it right there. Okay, so that's about right there. So that's about the envelope curve. So now what we're seeing is 82.26 volts of delta, or peak to peak. So we wrote down 82.26 divided by 2, multiplied it by 0.707, or square root of 2 over 2, and then squared that VRMS and divided by 50, which is the value of our resistance of the dummy load, and we got 16.91 watts, which compares to the 15 watts that is displayed on the Xiegu G90. Again, we're a little bit high in actual measurement compared to what is displayed in the Xiegu. Okay, we'll go ahead and change it to 20 watts now for the last data point. That's the maximum power that we can turn it to, and we can see that it's 20 watts on the Xiegu G90. So now we'll key up. And let's see what we get for the envelope. Not that much difference, it would seem, but a little bit more. So we can make sure we get those peaks up there. And then down here, similarly, we drop the threshold so that we make sure that we get those peaks down there. So then our peak to peak is 93.58 volts. So the value that we measured was 93.58, and we can go through the calculations. 93.58, enter. To get V peak, we divide by 2, so 2 divided by 46.79, multiply times 0.707, which is square root of 2 over 2. To get the VRMS, we get 33.08, and to get the actual power, we have to square this voltage. This is the square of voltage RMS. So we go purple x squared, and then 50 divided by. and that gives us 21.88.886. So I rounded up to 21.89. And that's the actual power that we're measuring with our experimental setup, and that compares, as expected, a little bit higher than what is displayed on the Xiegu G90, which is 20 watts. So that concludes this experiment. I mean, we've essentially used an experimental setup to measure our actual power output by a transceiver using a dummy load and an oscilloscope.